The first observation I wanted you to make was about symmetry. Now, throughout any curve on Friday, you should have noticed the same symmetry patterns. So pod 3, if we have a function where we have a sine theta, whether it be a circle, a rose, or a unison, what are we symmetric about?
The y-axis.
We are symmetric about the vertical axis. Yes, I'm going to call it the vertical axis since technically we don't really have a y-axis. Okay. I guess I also should say we are going to be graphing some polar graphs today. So if you want some polar graph paper for your notes, I'll leave these up here if you need to come get them. Okay. All right. So if a function in polar mode with a sine theta is symmetric about the vertical axis, what happens if we have a polar function with a cosine? Pod 4. We have symmetry with respect to the horizontal axis. And remember, the horizontal axis is also called the polar axis. Okay, so if you write horizontal, that means the same thing. That is fine. Okay, so the first thing I want to talk about is how to make a circle. Now, technically, a circle is a special rose curve. It's like a rose curve with one petal, okay? But I would like to classify it as a circle. So there are 3 ways to make a circle. Okay? From your discovery sheet, does anybody remember how we make circles? Okay, so r equals like a number times cosine theta, you said was 1. Okay, what would be another way? Okay, r equals a number times sine theta. What's that third way I'm trying to refer to?
R equals just a number.
R equals a number. All right. So if r equals a number, remember that means we have a circle with the center at the pole. And what would A be referring to? So the radius, right? A would be the radius all the way around, and we would have the center at the pole. Now, in your discovery activity, you talked about these 2 circles. R equals A cosine theta, R equals A sine theta. Okay. So we talked about on slide 1 that cosine means horizontal symmetry. So where does this circle go in relation to the pole if we have positive A cosine theta? Which direction? Is it going to go to the right? Is it going to go to the left? Is it going to go up? Or is it going to go down? It's going to be to the right. Cosine means we have horizontal symmetry. If A is positive, our circle is going to go through the pole, but it's going to be to the right of the pole. Now, this is something that you wrote down in your discovery activity. A refers to what about the circle? Huh? A is the diameter, okay? So it stretches all the way to A, but really that's the diameter since the edge is on the pole. Kelsey, if we wanted this circle to be on the left side instead, what would need to be different about our equation? Okay, if A is negative, our circle would be to the left of the pole. Okay. Then if we have a R equals A sine theta, okay, we already talked about how sine means we have vertical symmetry. So we have a circle that goes through the pole. Oh, that is terrible. I'm going to have to redraw that. I'm sorry. Goes through the pole with a diameter of A. If we had a circle that was below the pole, what would be different about our equation? A would be negative. So the sine and cosine kind of help us figure out, well, for sure what our symmetry is. So in the case of these circles, where does it go in relation to the pole? Okay. The pole is important for all three of these circles. This first circle is the center, R equals A, right? For these two, the pole, the edge of the circle goes through the pole. All right, so we are going to graph a circle. Okay, so go ahead and write down R equals -5 sine theta. For every graph that I will have you do, whether on a worksheet, a quiz, or a test, you will be given this information to fill out. Okay, so it's going to be on all of my slides that we do for graphing, so you get used to that idea. Okay, like I said, if you wanted polar graph paper, I have some up here on my front table. I meant to say that before we started. Okay, so for sure, every time we get a polar equation, we need to decide on its shape. We have R equals -5 sine theta. We know the shape is a circle, so that's what we're going to write. Okay. I will always have you identify the max R value, which is just the furthest away we get from the pole. Okay, Gabe, what would it be? 5. Well, we're going to say 5 because we're just talking about maximum, right? But 5 is going to be the furthest away we get from the pole. Okay? Now, number of zeros and zeros we'll get to here in a little bit, all right? But when you graph a circle, it is only going to take us from 0 to pi to actually get this circle drawn. If we have R equals A cosine theta, or R equals A sine theta, if we plug in values from 0 to pi, we will get our full circle. Okay, so we know that this circle is going to be below the pole, right here. Okay, so let's just talk about the points that we use to draw this circle. If we plug 0 in for theta, what do we get for our R value? -5 sine of 0 would be 0. Okay. If we were to plug in pi over 2, what would we get for our R value? What is -5 times the sine of pi over 2? -5. So at pi over 2, we're going to go backwards 5. And then if we plug in pi, the R value becomes 0. So we start at 0, 0. We rotate to pi, -5 pi over 2. And then, oh, I just knew that right away that wasn't going to happen. It's not terrible. I've had better circles, but that's okay. All right. Now, let's just look at the numbers here. When we talk about zeros, we're not talking about where we hit the x-axis because we're not in rectangular coordinates. We're actually talking about where we hit the pole. So when we drew that circle, how many times did we touch the pole? Twice. Which means we would have two zeros. We have a 0 when theta is 0, and we have a 0 when theta is pi. When we plug 0 in pi and for theta, we get 0 for r. Okay. Graphically, that's pretty easy to see. From here on out, we'll use algebra and trigonometry to help us find those values.
So where did the third significant point go?
Pi is 0, r is 0, so we just come back to the pole.
Oh,
Okay. And like I said, when we graph a circle, it's only going to take us from 0 to pi to get that drawn. Okay. And for a circle, you can, you know where it's going to be, but for your significant points, 0 pi over 2 pi will be sufficient. Okay. Circles are kind of boring though, right? Those flowers were a lot, they're simple though. The flowers were nice and pretty, weren't they? Okay, the flowers is where it really gets cool. So we call those rose curves. Okay, and I want to talk about as much as we can about rose curves before lunch. So rose curves are in this form. They look a lot like the circle, except there is a coefficient in front of theta. So we need to talk about a few things. We need to talk about, there's 3 different things that this tells us. A tells us something, sine cosine tells us something, n tells us something. Okay? We already know what sine cosine tell us, right? Tannen, what does sine cosine tell us?
Symmetry.
Okay. So this is going to have horizontal symmetry. This one's going to have vertical symmetry. That's going to be the only difference in terms of sine and cosine. All right. Let's talk about what A means. And then let's talk about what N means. So Finn, were you able to figure out what A told us about those flowers?
It told us like how far the curve would go up from the pole.
Okay, good. So we could describe that as max R value, okay? Or we could describe that as the length of the petal. Okay, which is probably what you're going to tie it more to than max R, okay? But the length of our petal is going to be whatever that A value is. Nicole, do you remember what N told us about those flowers? What do you mean by up or down? Well, since we just classified this as max R, I think that A would tell us that. Like, that would tell us how far we would go out for our flower petals. Okay? What's one thing that we haven't identified about our flowers that we would need to know? How many? Good. So N stands for the number of petals. Is it really just as simple as there are N petals? No, we had to look for a different pattern, didn't we? What was that pattern?
If n is odd, then that is the number of petals, but if n is even, then 2n is the number of petals.
Okay, so if n is odd, we have n petals. If n is even, we have 2n petals. So we have to double it. Okay, what actually happens, for those of you who did some or intricate observations. Technically, both of them have two end petals, but what happens with the odd ones is that they overlap. So if your N is 3, technically there are 6 petals, but you only see 3 of them because they trace over themselves. Okay, so what we're going to find is that if we have an odd number of petals, it's only going to take us from 0 to pi to draw our rose curve. But if we have an even number of petals, it's going to take us from 0 to 2 pi to draw our rose curves. Now, what we're going to do is we're going to use symmetry to really help us out. Okay? If we have 3 petals, what's going to be true about those 3 petals? They're going to be evenly spaced apart. And same would be true about 4 petals, or 6 petals, or 8 petals. Okay? We're going to space them evenly apart. So we're going to use that knowledge to help us. I am not going to make you find every single significant point, but we are going to have to find zeros. Those are going to be important. But once we know where one petal is, we can figure out where the rest are just by symmetry. Okay? So we'll take a couple of shortcuts there. Okay, so we're going to do 2 examples today. We'll probably start discussing one before lunch and finish it after lunch. And then my goal is to get you your worksheet. Yes, I said worksheet. So that you can do at least 1 or 2 problems before you leave. Probably 1. We'll see how time goes. But we're going to identify everything about our rose curve and then put it on paper. All right? So, here it is. R equals 4 sine of 2 theta.
Will this be on the non-calculated portion?
Yep. Obviously. Okay. There will be no calculator for your quiz Wednesday. And then your test next Wednesday will be half calculator, half non. Basically, anything polar will always be on the non-calculator portion. Okay? All right. So the shape of this, we know that it is a rose. But I need you to tell me a little bit more specific information than that. It is a rose with how many petals? 2 petals?
4.
4 petals? Do you agree about 4 petals? Okay. Since N is even, we have to double N to get the number of petals. Okay. Go ahead and skip down because I want to show you another graph and we're going to talk about how many petals it has. Nope, we're going to stick with this. I'm going to change my mind. Sorry, I was going to pull an audible, but I'm not. Okay, max R value. Sydney, what would it be? 4. Okay, that's because of this 4 right here. So we have 4 petals, and because of the A value, they're going to be of length 4. Okay, now the zeros, we are going to wait until very last to find the zeros. Okay, we're going to wait until last to find the zeros. As far as significant points go, I want at least 2 of them. I want where your first 0 is and where your first petal is. And then from there, I don't really want you to write them down. I just want you to graph. Okay? So we are always, always, always going to start by plugging in 0 for theta. That will always be your first significant point, no matter what graph we are talking about. Okay? If we plug in 0, what do we get for R? 0. We begin our rose curve at the pole. This is always going to happen with sine, isn't it? the sine of 0 is 0. So anytime you have a rose curve that involves sine, we're going to start with the pole. Now, the trick here is to figure out where our first petal is. Okay? It's going to be different with each equation. So what I want you to think about from now until 1 o'clock when we start back up, how are we going to figure out what mathematically do we need to think about in order to know what angle that first petal is going to be placed at? All right? So you think about that. When we get back from lunch, we will talk about it. Yes. All right, so we need to determine where that first petal goes. What do we know about the first petal? Or what do we know about any petal? Okay, they should all be the same. We have 4 petals, 1 in each quadrant. This is true. What do we know about how long they are?
They should be 4.
They should be length 4, right? And if they are length 4, thank you. What value in this equation would represent the 4? If each of them have length 4, what does that represent up there? But on a specific angle, what would be 4? The R value, correct? Like we want to know at which angle do we have a length of 4 so we know where to put our petal. Does that make sense? Okay. So our R value for our petal would be 4. Okay. Which means sine of 2 theta would equal 1. When is the sine equal to 1? At pi over 2. So 2 theta needs to equal pi over 2, which means theta equals pi over 4. So what we did, we plugged 4 into our R because that's how long our petals are. We got a value of pi over 4. So at pi over 4, we know that we have our first petal. Okay. Now, I think Amanda said it earlier. There's 4 petals and they have to be evenly spaced apart. I can't remember who said it, but we have to have 1 in each quadrant. Maybe that's what she said. Okay. So if we have a petal at pi over 4, and we have 4 petals to spread out over the course of this rotation, how far apart are they going to be? Okay, 90 degrees, or pi over 2. Gabe, how about you tell me how you got that pi over 2?
I think she said C would be pi over 2 because
Okay, so we're taking our full rotation 2 pi and we're splitting it into 4 equal parts.
I'll go with that.
Okay, so there's 2 pi radians split over 4 petals, so each petal must be pi over 2 apart, right? So if there's a petal at pi over 4, then there should be a petal at 3 pi over 4 and 5 pi over 4 and 7 pi over 4. Okay, now I don't really care how you draw this. You can go like this for all I care, but I will show you how your calculator is going to draw it. They're going to draw it like this. That was not my best effort either. want to try to keep the petals the same size. But there we go. There is our rose curve. Okay? We plugged in 0. We got a value of 0. So then we had to do some math to figure out where that first petal is. Okay? From there, I don't care about the other significant points. We just use symmetry to draw this. Now, we started our rose curve here, and then we drew 1, 2, 3, 4 petals. How many times did we hit the pole? But we do count the starting point. So we start at the pole, that's 1, and then we draw 4 petals. So there are 5 zeros. Okay? If we start at the pole, there's going to be an extra 0. That's going to happen. Okay? Now, how do we find zeros? When we talk about zeros, what is 0? R. We only have 2 options, R or theta, right? If we're talking about zeros, we're talking about where R is 0. So to find zeros, we're going to set R equal to 0. Okay? Well, when we divide that 4 over, we get 0 equals sine of 2 zeta. Okay? We need to list places where sine is 0. So our angle, 2 theta, equals, where is the sine 0? 0 and pi and 2 pi. How many zeros do we have? 5. We better list 5 numbers. So where's the next place the sine is 0? 3 pi. Where's the next place sine is 0? 4 pi. So our zeros are at 0. We're going to have to divide both sides by 2, right? So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. We set R equal to 0, and then you literally just need to list as many numbers as you need zeros. Okay, so if we needed 8 zeros, we would have to keep going with 5 pi, 6 pi, 7 pi, etc. Yes?
Do the zeros ever go past 2 pi? Because, like, that's one rotation.
No. Now, in this list, they have to, but once you divide by this coefficient,
Right.
they will not. Okay? And like I said, if there's an odd number of petals, they'll be between 0 and pi.
Oh.
Okay. So let's do an odd number of petals and a cosine one so you can see some differences. Okay. So since Jackson brought that up, there's an odd number of petals, which means it's going to take us from 0 to pi to get this drawn. All right. Since it's cosine, our symmetry is going to be a little different. Okay? So when I ask for the shape, you're going to tell me rows. And then the number of petals would be how many, Tannen?
Oh, 3.
3. Good. And the length of those petals would be what? You? Uh-huh. And so we're going to put that on max R value. There'd be 5 of them. Okay? Now, actually, these cosine rose curves are a lot nicer to write. Okay, and I'll show you why. Remember, you save zeros for the very last. You want to save those until after you graph it because you need to count how many zeros there are going to be. For your significant points, I only need 2 of them, all right? And you're always, 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 always going to start with theta is 0. When theta is 0, what's the cosine of 0? Huh? 1. So our R value is? Oh, that's so nice. What did that coordinate give us? Our first petal. We don't have to do any work to figure out where our petal is. That's why cosine ones are nicer, because you already know where the first petal is. Okay? So all we have to do is figure out how far apart these petals are. I don't care if you think about this in degrees or radians, but you need to do the calculation somehow. We have 2 pi radians to split up over the course of 3 petals. Or you have 360 degrees to split up over the course of 3 petals. So your petals need to be 2 pi over 3, or, that is, thank you, I was like, that's not looking right. 2 pi over 3, or 120 degrees apart. Okay, now, I plotted where my 3 petals are. Everybody watch me draw it, and you're going to count how many times we go through the pole. Are you ready? Three times we go through the pole. What does that tell us? We have 3 zeros. Excellent. Remember, zeros just mean that R is 0. And when we divide by that 5, we really want to know where the cosine of 3 theta is 0. Okay? You now appreciate chapter 5. Chapter 5 is helping you with all of these zeros. Okay? So, we want to know where the cosine is 0 and our angle is 3 theta. We want to know where 3 theta is 0. So, the cosine is 0, first of all, where? Pi over 2. Next place, 3 pi over 2. We need 3 zeros, so we need 1 more. 5 pi over 2. Those zeros will always be pi apart. Excuse me, pi apart. Okay. So then when we divide by 3, we have zeros at pi over 6. 3 pi over 2 divided by 3 is just going to be pi over 2. And then 5 pi over 2 divided by 3 would be 5 pi over 6. You'll notice that since we have an odd number of petals, those zeros are all between 0 and pi. All right? That's what happens there. Also, for your significant points, I told you I want 1 petal and 1 zero. Since we have the petal, go ahead and fill your first 0 in, and then you don't have to do anything more with those significant points. Tomorrow, when we talk about linosons, we will do more significant points, but with roses, I only need 2. All right. We have 10 minutes left, so I'm going to have you do a problem. Now, on your worksheet,